Hello, this video we will continue on where we stopped last time on ranking cycle, but this time we'll, like I promised, I will make some modification on this ranking cycle. For example, if it is going to be superheated, right? So I'm actually going to make a note if it's superheated. Okay. So let's go back to this chart. We still have these four components for ranking cycle, and however the change happens to TS diagram here. When we go from A to B, we assume B is saturated vapor. So for today, if it's a superheated, this is no longer saturated vapor. It's going to be superheated vapor. So if it's a superheated vapor, our B is no longer stop at the saturated vapor line. It's going to continue stay at this constant line for the pressure and maybe get somewhere, let's see, maybe get somewhere here, right? So that's going to be our new B. This is our B for superheated vapor. So in that situation, then go through from turbine B to C. It's still isentropic, so it's still going to be straight line going underneath. And however, now this is where going to be our C, new C will be. And then from C to D is still condensing. We'll have that. And from D to E, it's going to be go through one. Let's see. Through one low pressure to the high pressure, isentropic, and E to A, if we assume A is again saturated liquid, it's going to be like this. So this is going to be our new shape. This blue boundary line going to show our superheated. Okay. Then I'm actually going to make another modification. So sometimes not only it's superheated and the change happens at D. When you go through this saturated liquid condensing, it might not be stop at saturated liquid. It might be stopping at compressed liquid. I'm actually going to use a different color. Use purple. So it's going to be compressed liquid. Or sometimes people call it subcooled or called a subcooled liquid. If that's the situation, how will our TS diagram change? Again, we still have superheated vapor, right? So we're going to have this fancy ranking cycle chart consider both superheated and subcooled, okay? So B is going to be superheated and D is going to be subcooled. So this purple line, so we're going to go from A to B, we're going to add heat to it. So I'm using this, purple doesn't really show well. Okay, we'll try. So from A to B, B is going to be superheated and going through the turbine, isentropic, goes to the C, and C, the D does not stop as saturated liquid. It's going to be continue at this constant line during this condensing process, and it gets to here. That's going to be our new D. It's a compressed liquid. And then going through the pump. Pump is isentropic process. It goes straight up. That's going to be our E, right? Compressed liquid. Then we're going to start to add heat from E to A. That's going to be a compressed liquid to saturated liquid. And then continue to add more heat. It's going to be saturated liquid, become saturated gas. So that's going to be our new fancy ranking cycle. Consider both superheated vapor and compressed liquid. Okay, so I'm actually going to make this a little bit more prominent I don't know if that helped. You can see it. So that's basically our ranking cycle for this situation. Why do I want to point out that? Because for each problem, you want to be flexible. You want to know whether B is at superheated or saturated. Oh, you want to know D, is D at a saturated liquid or or compressed liquid? If they are at those situations, you're gonna have to draw corresponding correct TS diagram. So that's all for this one. And in the next video, we'll look at example and for Rankine cycle. See you at next one. Bye.